Hello, class. This is your Simple Motion Part 1 lecture. Tomorrow we're going to do Part 2. I am keeping to my promise of only one page of notes a day. To give you an idea, this is what my one page of notes today looks like. So there's a lot, but not a whole lot. A fair amount of it is pictures. Just try to keep those pictures small, and you'll be fine. All right, so these go well with our lab that we already did. Now, we did the lab first on purpose because I wanted you to experiment with it and experience it before you knew what you were doing. That's on purpose because now when I lecture, you'll have something to relate everything I'm saying to. Trust me, it works well. All right, let's go on. We've already spoken about position. Position is measured in meters. We represent it with X, and it is where you are on the football field. You can see the number line that I put up here, and it sort of demonstrates what I am talking about, where you can exist anywhere on that number line. Now, in physics class, we'll always have a positive or a negative in front of a number. Always. Because the positive and negative tell us things. For position, the positive means that it's to the right of 0, and negative means to the left of 0. Another note while I have the number line on the board. In math class, they tell you that -5 is smaller than -1. In physics, that is not true. -5 is bigger than -1. It's just to the left instead of to the right. That's the only difference in physics. All right, moving on. Now, the change in position is called displacement. All right, so we already had position. Now we're talking about how that position can change over time. We represent it with delta x, where delta is a little triangle. It's actually a capital Greek letter. Displacement, or change in position, is also measured in meters, and it can be defined as how your position changes from beginning to end. And it tells you which direction you went. So you can see on the screen there that in red, I have a displacement of +3 meters. That tells me that I went 3 meters to the right. And in blue, I have a different displacement vector. And it shows that I went -2 meters, or 2 meters to the left. The only thing I care about is, and you can see on the equation, the final position and the initial position. Nothing else matters for displacement. So for my blue arrow, I started at +2 meters and I ended at 0 meters. So in my equation, I would do 0 minus +2. All right, and 0 minus +2 is -2 meters. Now, if I'm doing the red arrows, my final position is +4, and my initial position is +1. So in my equation, I would have +4 minus +1, which would give me +3 meters. All right, so now let's do a problem. Let's say that I have this. Here's my number line, and I start at the +1 mark, and I end up at the +4 mark. All right, just what I was talking about. +4 minus +1 gives me +3. And here's how I would write that. Delta x equals +3 meters. Or I could give a displacement vector. A vector is an arrow. A vector is a number that also has a direction. So if you say that you ran a mile, that's not a vector, because all it tells me is that you ran a mile. If you say that you ran a mile west, that is a vector, because it tells me how far you ran and in what direction. So in this case, I ran 3 meters to the right, or positive. All right, now I could zoom in a little bit. Instead of doing it for just the very, very beginning and the very, very end, I could do it for each second. So here we have a motion diagram, which means that each dot is 1 second. That means that I started at +1, 1 second later I'm at +2, and so on. And if I did the math, I would find that each second I went +1 meter. In other words, 1 meter to the right. And I did that each second for a total of 3 seconds. which means that I have position and time, so I can graph this data. Bam, here's my graph. At second 1, I'm at positive 1 meter, and at second 2, I'm at positive 2 meters, so on. Now, with a graph, I can slap a best fit line on it and find the slope of that best fit line, which in this case is positive 1 meters per second. But what does that slope mean? It's something called the velocity, represented by v, measured in meters per second, and it tells you how far you went in 1 second, in other words, how fast you're going, and what direction. So it's like speed, but it is not the same thing as speed. All right, and average velocity is the big thing we care about. Average velocity is the velocity if all you look at is the very, very beginning and the very, very end. Tomorrow we'll talk about zooming in a little bit more than that, but for right now, let's ignore it. So the equation for average velocity is right underneath me. V average equals delta x over delta t. In other words, the average velocity is equal to the change in position, total change in position, divided by the total change in time. Take those numbers, divide them, you get your velocity. So if we're here, we know the displacement is positive 3 from before. We know that it happens in 3 seconds. I know that because I can, count the dots. There are 4 dots, which means that I was here, and 1 second later I was there. 1 second later I was there. 1 second later I was there. That's a total of 3 seconds, 3 steps. So I got positive 3 meters divided by 3 seconds, which gives me positive 1 meter per second, which tells me that how fast I'm going 1 meter per second to the right. All right, which means, of course, that my best fit line slope is the same as my average velocity. That will always be true. If you take your position and your time and you graph it, and you make the best fit line, and you find the slope of that best fit line, that slope will be the average velocity. All right, that's it for today. Now I want you to go over to your page 11 instructions on Echo, and you're going to do your reflection. Ooh, actually, I take that back. First, you're going to finish doing and handing in your lab 2, because I see that not all of you have handed that in yet. Many of you have, but not all of you. So if you have not yet handed that in, finish it, hand it in. Then go to page 11 and finish that. And that's it for today. Today's a nice, easy day. If you have anything that you have not yet handed in, make sure that that gets handed in today, because I'm going to have everything updated as soon as possible. All right, there you go. And now, as a thank you for taking such diligent notes and being so kind to your sub, I have a surprise for you. This, turn your head, buddy, is my son, Derek. And that's your reward for taking such diligent notes. All right. Goodbye.